Some enzymes only work when they bind with something. There are some cleaners that don't work unless they bind with dirt. You can see the cleaner in the bottle. It's clean, shake it up, look at it, take the top off, smell it, close it, look at it, it's clean. But the minute you put dirt in there, the enzyme gets activated. Sometimes you can also control enzymes by having them compete. So let me give you an example. And by the way, for this slide, you will not need to tell me the difference between competitive and non-competitive inhibitors. Well, let me do this. You have your study guide? Let's look and see if competitive and non-competitive inhibitors. It is on there. All right. Then we got to know it. That's right. Let's see it. Okay. No. So you ready? By the way, why don't you tell me what kind of an enzyme this is? Does it look like a simple enzyme or a conjugated enzyme? Good for you. All right, so we've got a simple enzyme in both cases. Just because there's a little thing here, that doesn't mean anything. So here's what's happening. You see that this is an enzyme and this is a little binding site. And I told you that there's two things that always go together, an enzyme and a substrate, right? So do you notice that here's the normal substrate that fits in here? Do you also notice that this piece looks similar to this piece? Agreed? And if this piece gets in here, then a reaction is not allowed to continue, and in this case, a reaction is allowed to proceed. So here, we have competitive inhibition. These two guys are competing for this site. You see that? So you can actually shut down an enzyme by adding a competitive inhibitor. When you add a competitive inhibitor, this will go in here, and then the enzyme will not allow the reaction to continue. A non-competitive inhibitor is going to be this way. Notice that this is the way substrate looks. When the substrate fits in here, I need you to understand that. Let me make sure I do this right.